So let's see how to implement this prefix sum and how this prefix sum can reduce the time complexity of a particular program more efficiently. Okay, so let's see how it does that. Okay, so this is the second part of the prefix sum. I would highly recommend you to follow the first part of the prefix sum to know that how a prefix sum array is created. Okay, so let's see one problem. Suppose you are given an array in which you have been asked to find the sum between a given range. So you are given a start index and you are given an end index. So you need to find the sum within this range. Okay. So you need to find the sum from 3 to 6. Okay. So what is going to be your basic approach for this? Okay, you can simply loop from the third to sixth index and keep on adding the elements of the array to a sum variable. So here the sum is going to be 7 plus 4 plus 2 is equal to 16. Okay. Uh, so what is the time complexity for this? Okay. So the time complexity for this program will be big of n. Okay. So time complexity for this program is going to be big of n. Okay. What other approaches you can take? Okay, the second type of approach which you can take, so this is approach 1. Okay, so this is approach 1. Okay, so the second type of approach which you can take is something like this. Okay, so approach 2 is going to be something like this. Okay, so you are going to find the sum from 0 to 6th index. Okay, so that is 25. Okay, and you need to subtract the sum from 0 to 2 index. Okay, so you need to find the sum from 0 to 6th index. Okay, and then we are going to subtract the sum from 0 to 2 index. Okay, you are getting my point. Okay, so to find the sum from 0 to 6th index, so you are going to have a for loop from 0 to 6th index and keep on fetching the values in the array and calculate the sum. That the sum is going to be 25. Okay, and you are going to need another for loop to iterate from 0 to 2 and you need to keep on calculating the sum again. So that's going to be 9. So your total, so your sum from index, so your sum from index S to E in this case would be sum 1 minus sum 2. Okay, okay, so that is going to be 25 minus 9, that is going to be 16. Okay, so what's the time complexity for the approach 2? Oh, okay, what's the time complexity for approach 2? So for the first for loop we are going to have a time complexity of big of n. So for the second for loop you are going to have a time complexity of big of n. Okay, so the total time complexity in the second approach is going to be, so the total time complexity in the second approach is going to be big O of n for the first for loop plus big O of n for the second for loop. So the total time complexity is going to be big O of n. Okay, so can't we have a method to reduce this time complexity to O of 1? Okay, like can we just calculate this by just having O of 1 time complexity? Okay, so for that you can use a prefix sum array. Okay, so the prefix sum of the above array is going to look this way. Okay, how I created this array, you can watch the part 1 of this video. Okay, okay, so to calculate the sum from range S to E here, what can we do? Okay, see, if you closely observe in the second approach, what I did is I calculate the sum from 0 to 6th index. Okay, that came to be 25. Okay, and I calculate the sum from 0 to second index. So I calculate the sum from 0 to second index, that came to be 9. Okay, so are you able to find something in the prefix sum? We already have this value. Okay, so the sum from 0 to 6th, we already have the value as 25 in the end index. Okay, and the value from 0 to second index, we already have that in the second index, that is 9 here. Okay, that is 9 here. Okay, okay, so prefix sum already has this value. Okay, if you closely observe this, you will be able to understand. Okay, I would highly recommend you to watch the previous video where I have taught how to create a prefix sum array. Okay, so we already have this value, so we need not again loop over the prefix sum array. What can we do is that if you need to find the sum from start the index to this end index, then what we can do, we can simply subtract the prefix sum present at the 6th index minus prefix sum present at the second index, that is prefix sum e. Okay, that, so let me just copy this. Okay, so what can we do? Okay, so let's see. So what can we do in prefix sum array is, so to calculate the sum, we can simply take what is the prefix sum of e, that is already 25. Okay, and what is the prefix sum of s minus 1? Okay, this is the s index and s minus 1 index is 2, so what is the prefix sum? It's 9. Okay, so we are getting 16. Okay, okay, so what happened here? So we already have the sum from 0 to 6 index, that is 25, and we already have the sum from 0 to 2 index, that is 9. So we are simply subtracting 25 minus 9 and we are getting the sum of this index, sum from 3 to 6 index. Okay, so if you put this mathematically, so it will come prefix sum e minus prefix sum s minus 1. Okay, we need to calculate the sum from s to e, so prefix sum at the e index minus prefix sum at s minus 1 index. Okay, okay, so this is how you get this expression. So prefix sum e minus prefix sum s minus 1 would give you the sum from range s to e. Okay, I hope you are getting what I am trying to explain. Okay, so let's see another example. Okay, so here also you may have a question like, to do this, okay, to calculate this, okay, prefix sum e minus prefix sum s minus 1. Okay, we just took a time, so it took just the time complexity of big of 1. Okay, okay, so to do this simple calculation, just 25 minus 9. Okay, it took big O of 1 time complexity. Okay, uh, so you may be having a question to calculate the prefix sum array itself. It took time complexity of big O of n. Okay, and here to calculate the sum within a given range, it takes big O of 1. So if you calculate the total time complexity, so this is going to be again big O of n plus big O of 1. So that will be big O of n. So here you may be having a question like, so how did the time complexity reduce? Here also we were taking big O of n, here also we were taking big O of n. So how did we reduce the time complexity? Okay, you may be having this question, correct? uh, Not like to calculate the sum within the given range, it took simply O of 1. Okay, but the creation of the prefix sum array itself would take big O of n. Okay, so where did we reduce the time complexity? Okay, in this method also it was taking O of n, here also it was taking O of n, here also it's taking O of n. Okay, okay, so where did we reduce the time complexity? So let's understand this by another problem. Okay, so the next problem which I am going to explain, so in there you would get a clear idea like how, in which conditions that prefix sum is going to reduce the time complexity to a great level. Okay, so let's see the next problem. So let's see another problem where you would understand the magic of this prefix sum array. Okay, suppose we have array where we have elements 8014441. Okay, and we need to find out an index where the sum of the element in the left of the index and the sum of the index in the right of the index are equal. So in that case we would say that particular index is a equilibrium index. Okay, so let's consider the best case. Okay, so let's consider the best case. Okay, so let's consider that the equilibrium index of the array is here. Okay, okay, uh, so you see the left sum here is 8 plus 0 plus 1, that is 9, and the right sum here is 4 plus 4 plus 0 plus 1, that is 9. So so the index 3 here is the equilibrium index, because the sum of the elements on its left is equal to the sum of the elements on this on so is equal to the sum of the element on the right. Okay, uh, so this equilibrium index, this can be at any position. Okay, it doesn't mean that it always has to be in the middle position. Okay, so this can be at any position. Okay, so this can be at 1 position, this can be at 4 position, considering the left sum will match with the right sum. Okay, so in a normal approach, what would you do? Okay, let's see. So so I know here the equilibrium index is 3. Okay, so let's consider it that way. Okay, in a normal case you have to loop from 0 to n minus 1 and keep on checking whether left sum is equal to right sum. Okay, so for our understanding, let us take the third index is the equilibrium index. Okay, because we are seeing that. Okay, okay, so how do you calculate it in a normal way? Okay, what would you do? You would create a for loop. Okay, from I is equal to 0, okay, till I is equal to till I less than equal to I minus 1. Okay, this one. Okay, then I plus plus. Okay, and suppose what to do here is you need to keep on adding the element to the left sum. Okay, left sum is equal to left sum plus a of I. Okay, and to calculate the right sum, what would you do? Okay, so you need, in the similar way you need to loop from I plus 1 till n minus 1. Okay, and here right sum is equal to right sum plus a of I. Okay, so what is going to be the time complexity of these two loops? Okay, these two piece of code. Okay, so here the time complexity is going to be big O of n. Okay, and here also the time complexity is going to be the same. Okay, big O of n. Okay, so If you add the time complexity of both these loops, okay, loop 1 plus loop 2, so what's going to be total time complexity? It's going to be big O of n plus n, okay, that is equal to big O of n, okay, that is equal to big O of n, okay. So here you see, okay, big O of n is the time complexity of just one instance of I, okay. Okay, in our problem, we already have created a equilibrium index array, and we know that the left sum is equal to right sum 9. The left sum is equal to 9. Right sum is equal to 9. We know that. Okay, so this uh, this code is only for the one instance of I. Okay, okay. Suppose you need to loop over the entire array, okay, for, so if you consider the outer for, okay, outer for loop, okay, so if you consider the outer for loop, okay, okay, so if you consider the outer for loop, then, so if you consider the outer for loop, means the for loop is executing, so if you consider the outer for loop, that is, we know that the equilibrium index here is at the index I, but in actual case you have to loop from 0 to n minus 1 and keep on calculating the equilibrium index for each value of I, okay. So if you consider that, the time complexity here would be big O of n into n, okay, so that is equal to big O of n square, okay. So this is huge, the time complexity is huge, okay, okay. Now, is there any pre-processing which we can do to reduce this to O of n? Yes, we have a concept called prefix sum, okay. So I already have created the prefix sum array of the above array, okay. So in order to calculate the left sum at the index 3 and the right sum at the index 3, what can we do? Okay, so this is the normal approach, okay. Okay, so if we need to take prefix sum approach, so what do we do? Prefix sum array. So I have already created the prefix sum array from the above array, and let's see how the time complexity gets reduced. Okay, so we know that our equilibrium index is this, okay, third index, okay. So what's going to be the left sum if you consider this prefix sum array? Okay, what's going to be the left sum? So left sum is already pre-processed for you, okay, if you use this prefix sum. So left sum is equal to simply prefix mm, prefix sum of I minus 1, okay. That means the prefix sum present in the I minus 1 index, that is 9. So you are not looping it from 0 to 2 and calculating the left sum. See, it's already present in the second index, that is I minus 1. So the prefix sum at I minus 1 is equal to your left sum. So so what time complexity did we take to achieve this? So it's big O of 1, okay. Similarly, if you calculate the right sum, so if if you calculate the right sum by using the prefix sum array, so considering this is the equilibrium index, third index, so the right sum will be from 4th to 7th index, that is I plus 1 to n minus 1 index, in that range, okay. So do you need to create a for loop again and loop from I plus 1 to n minus 1 index? No, like as I explained you in this, the sum in a range problem. So if you are calculating the sum in a range, okay, so your the sum in that range is going to be this. Okay, so if you use this for expression that we derived in the previous explanation here, okay, so let's see what happens. Okay, so uh, so here what we are able to achieve. So what is the end index here? Okay, end index means why I am calculating the end index is here the prefix sum of e is mentioned. So what is the end index here? End index is n minus 1. Okay, this one. End index is n minus 1, this one. Okay, and what is the start index here? Why I am calculating start? Because here prefix sum is equal to s minus 1. So what is start here? Start is I plus 1 here. Okay, okay, if this is I, if the equilibrium index is I, the next index will be I plus 1, the previous index will be I minus 1. So the start index here is I plus 1. Okay, so start is I plus 1. Okay, if you put this value of e and x in here, okay, what do you get? So here it becomes n minus 1 and s becomes I plus 1. Okay, the plus 1 and minus 1 here will cancel out. Okay, so what do we get? So the right sum is equal to prefix sum of n minus 1 minus prefix sum of I. Okay, so again, what time complexity did we take here to achieve this? It's again big O of 1. Okay, if you compare it to the normal approach, so the left sum it took time big O of n, right sum it took big O of n to calculate. So here left sum it took big O of 1 to calculate, here right sum it took big O of 1 to calculate. And if you consider the time complexity of creating the prefix sum, okay, so prefix sum array was created in a time complexity of big O of n. Okay, and if you calculate the time complexity of both left sum and right sum here, so it's big O of 1. Okay, so the total time complexity that we achieve here, okay, it's big O of n. Okay, so it's big O of n. Okay, so if you compare it to previous, so here it was big O of n square, and by using prefix sum it's big O of n. Okay, so this is a great reduction in time complexity. Okay, okay, here it's taking less time. Okay, so I hope you understand how prefix sum array and concept is able to reduce the time complexity here. Okay, uh, for people those who are watching this for the first time or trying to understand the prefix sum concept for the first time, it may be a bit difficult to grasp what I am saying. Okay, but if you yourself, by taking a rough pen and paper, try to iterate and see how this works, okay, then I am sure you will be able to understand this. Okay, so let me know if I was clear in explaining how prefix sum is able to reduce the time complexity. Okay, so thank you all for watching this video. Please like the video and subscribe to my channel. Okay, thank you.